So, holla to all you folk there in Uruguay. Hello. This is the third talk on the Australian lamb industry. And in this case, we're going to be talking about really a focus on eating quality and some of the really great things that have changed in the industry over time. If we think about lamb, we want it to be a high quality product that is tender and is attractive to consumers. And that's been very much the focus of the work in Australia over a number of years. Now, that focus on quality was really, I suppose, closely looked at in the 90s, when the whole idea of the quality of lamb presented to Australian consumers came to the forefront. And as a part of that, and the reason for that was that we did a baseline audit focusing on tenderness back in 1997. And what we did was we went to a whole range of different retail outlets. We purchased lamb loins across the counter, and we took those away, and then we tested them for various traits, including shear force, which is an objective measurement of toughness. So the higher the value, the tougher the product. And we did that 4 times during the year in 3 of the major cities of Australia. And the reference is included in this diagram for you to go and look at if you want to see more detail. Now, this graph shows the distribution of the shear force data that came out of that study back in 1997, 98. And you can see that there's 20% of the samples, of the nearly 900 samples, that had a shear force values above 49 newtons. And at the time, it was considered that this level would be representative, what would be considered tough for lamb. So it was suggesting that about 20% at that time would have been considered tough. Now, one of the other interesting things about this audit was that, of course, we were purchasing the product across the retail level counter. And you can see here the shear forces on the left-hand side, and along the bottom are the dollars per kilogram. So remember, this is back in the 90s. But you can see quite clearly that it didn't really matter if you were to purchase expensive lamb, that it was necessarily going to be all tender. In fact, there's a wide range. And this in itself is interesting and important feedback and information, because what it says is that marketing is overriding the eating quality of the product at the time. Now, this data really stimulated the industry to look at targets, and there was a target set in 2000 to get the industry to be worth $2 billion. And if you remember one of the other talks that I did back in the 90s, the industry was worth about $1 billion. So this was a major target. And the focus was to actually support processes in this with a focus on meat quality, and to provide a system to be able to grade sheep meat for eating quality. And a major collaborative program involving lots of different R&D providers in Australia, across Australia, was undertaken. And that project was called the Sheep Meat Eating Quality Program at the time. Now, based on the results of this, this then was developed into Meat Standards Australia for sheep meat. And that was because in the 90s, the program was started for beef. And in 2000, this research for sheep was undertaken with lamb. And we were able to work on the basis of the knowledge that had been accrued already in the beef industry, and value add to that for the sheep industry. And as I said, that system has become known as Meat Standards Australia. As I pointed out, multi-organisational program. And the unique thing about it was based on using real consumers as the arbitrators of the quality. So not trained taste panels, but real consumers, real sheep meat, lamb consumers. And the basis of the approach was to look at all the different critical control points across the chain, right from conception, right through to the consumer, using the consumer, as I said, as the final arbitrator. And here, we have the tenderness, the juiciness, the flavor, and the overall liking as the 4 traits that we used. And lots of different factors along the way that can impact on meat quality, such as how they're hung, tender, stretched, or Achilles hung, the chilling regimes, how long you age it for, cooking methods, which are very important, and then sort of on the pre-slaughter, more production side, the selling method, genetics, sheep age, and so on. So all these factors were looked at to see what their impact was on eating quality. And as I said, it was based on using real consumers, and consumers would be presented with samples of cooked meat, primarily cooked grilled to start with, but then roasting was undertaken as the program developed. And tenderness is scored on a 0 to 100 scale, juiciness, liking of flavor, and overall liking also. And then the consumers are asked to actually rate the lamb, whether it's unsatisfactory, whether it's good, better than every day, or premium. And every sample is eaten by 10 consumers. So a sample from a particular animal would be eaten by 10 consumers. And then that data is then averaged to come up with the score for that sample. Now, as I said, started off initially grilling the product, and the type of grill is what we call a clam grill. So it cooks at the bottom and it cooks at the top. And the product was essentially cooked to a medium rare endpoint at a certain temperature and controlled. And then that product that you see there would then be cut in half, and half would go to one consumer and half would go to another consumer. Now, what the program showed as we actually looked at where the industry was that to get maximum eating quality, we needed to control the rate of pH decline. And a target temperature for pH 6, hitting pH 6, was set at the time, based on the research, of between 18 and 25 degrees. Now, that target's been widened since then from 18 to 35. And this was for short-aged domestic product. In other words, product that was aged for 5 days. Now, initially, when we went out and measured pH decline in a number of abattoirs, we found that, in fact, only 3% would actually meet that target. And so it meant that to actually be able to achieve improved eating quality, we had to do something about the rate of pH decline. And that required a major change in focus. And this is a diagram of showing exactly what we would expect to be the ideal pH and temperature fall. And it was clear to us that to achieve that, the only way that we could do that effectively was by using electrical stimulation. And what that does essentially is increases the rate of glycolysis, and it increases the rate of pH decline. So you avoid what we call the cold shortening window up here, and the potential, particularly in lamb, to end up with a tougher product because it actually cools quickly and the pH is still high. So stimulation is designed to overcome this. Now, you can also get too much stimulation. That's less of an issue, particularly for lamb, given the size of the carcass. So the issue was, how would we achieve this? Because at the time, there was essentially only one abattoir in the whole of Australia that actually had electrical stimulation technology installed. Now, the great thing was that there was another program developing looking at electrical inputs to maximize different traits in slaughtered beef and sheep. And the reality is, this was based on the concept that electricity ain't electricity. In other words, you can vary the effects of electricity on muscle by changing the parameters. A new technology was needed. So in this photo, on the left up here, this is a high voltage stimulation system that was installed in one abattoir. This is very effective and was used in a hot boning situation so that they could pull the temperature and the pH down and then bone before the onset of full rigor. Now, the problem with this technology is that, as you can see, all the carcasses are on here being stimulated at the same time. So depending on how many carcasses are there, you get this average effect. In addition to this unit works at very high voltage and essentially has to be shielded from the workers in the abattoir, because if they were to touch that, they would actually probably die. It's working at about 2 amps and up to 1100 volts. Now, the new technology that was developed is shown in the picture on the right over here. And in this technology, what we have is a series of electrodes here, separated by insulators, so that every carcass gets an individual dose on every electrode that it hits. So a very different concept. And as I said, what we expect this pH temperature window to do: prevent cold shortening, improve meat tenderness, and hopefully also reduce product variation. So just to give you an idea of how things work. So that high voltage system that I showed you, here we can see it's got a constant voltage. And as the carcasses vary in their resistance, so will the current that flows through those carcasses vary. And in essence, you end up with an average effect across these carcasses because this is all one live rail. Now, the new generation technology, which is what we call it, works on an individual basis. And as I said, there's insulators here between each electrode. When the carcass actually hits that first electrode, this system detects the amount of resistance, and it's set up to vary the voltage in contrast to the high voltage system. And so the amperage actually is designed to stay the same. And so it alters the voltage accordingly to give you a constant amperage. And as a carcass goes along, it gets this repeated stimulation. The length of this stimulation unit is determined by your chain speed and the time that's needed for an adequate dose to go into the carcasses, something in the order of 35, say, to 45 seconds. Now, the actual electricity also is quite different in this case. So here we have a high voltage stimulation, and this is what we call a sinusoidal type frequency. Here we have the new, what we call medium voltage. So they're short square pulses that go up to about 300 volts. The consequence of this technology is, A, it uses lower voltage, but because it uses the square short pulses, it's actually safe. So it doesn't require the same amount of shielding in the abattoir, and is therefore more easily retrofitted, as we call it, into existing abattoirs without big changes to their chain. So constant current, individual electrodes, low voltage and safe. And this was a great thing to be happening at the same time that we knew that we needed to change the rate of pH and temperature decline. Now, some of the early data on this system in terms of eating quality was published in 2005. And the reference is there. You can see this is an old high voltage stimulation unit. These are the tenderness, average tenderness. Remember, this is out of 100. So this is a fairly good product. This is loin in terms of eating quality. And you can see the new system is actually quite comparable. In this study, not statistically different. The control, the unstimulated, is about 10 units worse off. In other words, scored lower. And in the rump, we can see a similar sort of effect. It's actually a little bit greater in terms of the benefit that you get from stimulating. So this was really encouraging that this technology was actually going to help us improve the eating quality of lamb in the Australian processing sector by the implementation of this technology. Now, the amazing thing is that this technology has been adopted almost exclusively across the lamb sheep meat processing industry. And I would estimate now, based on the data, that 90% of the product in Australia falls under this category. Now, what that's done is it's provided a platform for ensuring eating quality, but particularly for short age product, say aged for 5 days. And if you do some simple mathematics, you can see that the value of this is actually quite huge to the industry in terms of providing a premium. And even if a small percentage of slaughtered lamb was implicated, improved, it would be a massive improvement in the industry. Now, just very briefly, just to show you that there are other technologies that were also developed in this electrical space. One of those is immobilizers, and this has different electrical parameters. It operates on high frequency. The idea is to induce tetany, and the idea is that it reduces the kicking and the carcass movement before the animals actually get suspended on the chain. It reduces what we call kicking after stunning, which is dangerous, potentially dangerous to slaughtermen, because of course, if the animals are kicking, it makes it more dangerous when they're actually starting their work to skin the animals. Now, another thing that we also worked on at the time, and is actually still installed in one of our major abattoirs, was the idea of using electrical inputs to actually increase the amount of blood that you collect in the bleeding area. In this case, it's a low frequency system, low frequency and pulse width. We designed it so that there was no effect on meat quality. And the result is that basically you reduce what you call your biological demand, or your biochemical oxygen demand, because you reduce the amount of blood that ends up in the waste further down the chain, because you get more blood out at the start of the chain. That blood can actually be captured and then used for other products. And the reference there to that early work is given. So the take-home messages for this were: stimulation significantly benefits the Australian sheep meat quality. We've got to have that optimal pH decline, but it's also essential. Our work revealed that you actually monitor those electrical stimulation units, because you need to continually ensure that they're working at their optimal levels. So how do we define if a unit's working effectively? We need to measure carcasses, we need to manage it, we need to audit them, and we need to work out the temperature at pH 6. And that now is a requirement for all abattoirs that are registered under the Meat Standards Australia program in Australia, to monitor lots and to assess and make sure that their stimulation systems are working as they're supposed to. Now, you might remember that we did that audit back in 1997-98, and here's some comparative data. So here's some data from that audit, and you can see the spread of shear force. Now, at the time, we suggested that if it was actually, if a product was sort of over 49 newtons, which on this level here is sort of, it equates to somewhere around about here, that this product would actually be deemed unacceptable. Now, what we've subsequently found from this doing this MSA work was that, in fact, the tolerance level of Australians was actually lower than that, So in other words, they wanted an even more tender product, and we're looking at about 30 newtons. So we're actually looking at something that's in the order of this space here, okay? And anything above that would be considered now today unacceptable. And so in fact, the problem was greater than what we'd even anticipated early on. Now, if you actually put together the MSA system and the requirements for pre-slaughter handling, stimulation, aging, then you get a distribution like this on the right-hand side. And what you can see is we've reduced all of those very tough products going into the market. And so this tells us, gives us confidence that we've got a system here that actually can ensure that we've got quite high quality, eating quality lamb. Now, that program has been basically a carcass program. So you've had to have things in as a part of the protocol focused on carcasses. There's a real move to something similar to the beef industry, where we've got a cut by cook model. So recognizing the different cuts and the different cooking methods, and also looking at the predictors that we might use to predict eating quality of the product, because essentially, again, it's a trait that we can't easily measure, particularly when we use real consumers. And the model at the moment that's been looked at is to use hot carcass weight, lean meat yield. And if you remember from the carcass measurement talk that I did, we have lean meat yield ability, or the ability to now estimate that, particularly with the DEXA system. And then the other important trait is intramuscular fat. And as I also mentioned in that talk, we now have technology to potentially measure intramuscular fat. And so we've got the key inputs that we can use to make predictions for different types of cuts and the way that they might be cooked, whether it's grilled or roasted. And you can see right over here on the right that we can then grade the product. So 5-star is premium. It's right at the top. It's a very small percentage of the market, but highly desirable. And then 4-star, and then we get to the ungraded. So the key is, though, that we must be able to measure these traits: intramuscular fat, lean meat yield. And as I said in the other talk about carcass measurement, that's a field of work ongoing. And yes, there are some examples in Australia, but it still requires more work. Now, based on the IMF and lean meat yield, it's actually possible to produce a grid of the likely eating quality. And this is what's shown here. This is an example that was sourced from Meat and Livestock Australia. And you can see that as the IMF goes up, and up here, say 10%, and the lean meat yield is, like 50%, you might get an 80% eating quality score. But you don't get a big reduction by going to a lean meat yield that's 15% greater. So certainly being in this space is much better than being in this space here in terms of eating quality. And what that means is if you're down here, you're in 3-star, and that's actually not going to be graded. Here, you've got a lot of 4-star, which you expect, and then the premium. And so the majority of it is going to be in the premium. And as I said in the other talk about carcass measurement, you might remember that I mentioned that a company was offering a bonus if the IMF level was 5% or greater. And they would certainly want to be in this space here and up here, but there won't be many carcasses in this space. So that's one way to actually approach the prediction of eating quality. But as I mentioned, we're doing work on a technology called Raman spectroscopy. So what if you could actually measure eating quality directly with that particular technology? You wouldn't need necessarily all those predictors that have been measured. And I think that that's a space where there's going to be ongoing work. Now, another thing that we need to take into account when we think about eating quality is, of course, that increasingly less Australians have what we call an Anglo or British background. More of our product is exported than ever. And it's good for us to have good knowledge on how lamb is rated overseas. And a couple of years ago, a study was undertaken through the MSA program to actually take Australian lamb and two cuts, loin and topside, into the Chinese market, into the North American market, and test the product with actual consumers in those countries, benchmark against Australian consumers. And you can see here in this graph, which has got the eating quality score, that essentially there's a fair commonality between how different consumers with different ethnic backgrounds actually rate lamb. You can see in the top side, of course, that the Chinese were less favourable in terms of the tenderness of the top side than the Australian and the American consumers. And in terms of the loin, the American consumers rated it higher than both Australian and Chinese consumers. So this is important information to understand, as you need to always keep an eye on the markets to which you're exporting. Now, one of the issues with this work, of course, was, from my point of view, was that it was done on heavily denuded product. In other words, very little subcutaneous fat. And we know from historically that in North America that a country where they seem to drink a lot of chilled water with their meals, that if products are very fat, this leaves a very unsavory taste in the mouth. So it would be interesting for sort of non-denuded products to actually be tested to see whether it actually had the same effect. So what it means in essence too, of course, as we look at our industry, that there has been a requirement to differentiate cuts more and more. And as I said in the other talk, packaging is a big issue, and it's an evolving issue of importance. And we spend significant quantity of chilled lamb vacuum packed to overseas markets with shipping times of 8+ weeks. So if we're going to the east coast of the USA, it certainly would be at least 8 weeks. And on the local market, as I said the other day, packaging has become much more important and has really helped the development of the retail market. And we've got a shift gradually going away from what we call overwrap displayed meat to either modified atmosphere meat or vacuum skin packaging. And the latter is the best option and is now seen on supermarket shelves. The modified atmosphere, sure, it keeps the color nice, but there's good evidence that, in fact, it actually increases the toughness. When we think about packaging, there's definitely a need for more work on sustainable packaging systems. And here we've got some cuts just to demonstrate the variety now on the Australian market. Up here, we've got a mini roast. This is a knuckle. I said in the other talk, came out of the Trim Lamb campaign. This is vacuum skin packaging, so we don't have problems with oxidation. This is a great product and very nice for roasting. Here on the left, we have a butterfied lamb shoulder, and it's been marinated in rosemary and mint and vacuum packed. Again, a great product, slow cooked, tastes great. Here we have a high value product, lamb, eye of loin, vacuum skin packed, and would be very expensive. I think in this case, it's about $46 a kilogram, and that's a photo from a couple of years ago. On the lower side, we have a prepared shoulder roast that's been seasoned in garlic and herbs, and it's ready basically to heat up. It's been slow cooked. So we have this great diversity now of products that has developed, which has helped to underpin the continual stability of the lamb industry on the domestic market. So another thing that one might consider when we think about eating quality is actually the nutrient value of what you're eating. And to date, there hasn't been a lot of pressure to provide lots of information on this, but we do know that there's more and more brands they're identifying as organic or naturally produced. And we know from some survey work that we did a few years ago that the majority of consumers consider omega-3 fatty acids as important for lamb, along with iron levels. So there is an awareness of the importance of these things in the product that they eat. And trying to deal with this for all the Australian cuts that are in the Australian Handbook of Meat, a couple of years ago, we put together this thing called the information matrix. And this was designed to show us where the gaps in knowledge were. And we did it for a number of different traits. And this shows you the inside of that document. And for instance, we see here, we've got a top side cap off. This is the cut as it would be in the Australian Handbook of Meat, and the description of the cut here. And here we can see that we don't have any information on what the weight of that cut might be according to fat score or GR and carcass weight. We don't have any idea about these traits like the level of saturated fats or the health claimable omega-3s, EPA and DHA. We have a little bit of information on recommended cooking methods. By contrast, we have here the silver side, and we do have data that enables us to predict the weight of that cut out of various carcasses, and then using a particular serving size, work out how many serves we might have. We've got some eating quality data here on this particular cut, both from yearling and from lamb, but no nutritive data. And so what we've done is in a small way is set out to capture some of that nutrient data. And here we've looked at 5 cuts. They're all from grass-fed lambs, and they were determined over a number of different production line lots. And we can see here the level of iron is in the red and the level of zinc is in the blue. Now, a couple of things strike us from this data. Firstly, there is an obvious difference according to cuts in the amount of zinc. So if you want high levels of zinc, then you would eat the knuckle compared to, say, eating the loin. If you wanted good levels of iron, you could go for the loin or the top side. This cut here, this was the new one that we developed in the sheep CRC program called the compact shoulder roast. And you can see it eats quite well in terms of nutritive value. If we then extend that to look at the fatty acid composition, and remember these are in a grass-fed system, we've got here the level of DHA and EPA. These are the two health claimable omega-3 long-chain fatty acids that you would find in nutritional guidelines. And you can see here that all of these cuts actually got to a good level, is what we consider a good level in Australia for these particular fatty acids. But there is variation between them. You've got the lowest level here in the eye of shoulder and the highest level in the top side. So what that means is that you can actually then differentiate product based on nutrient value. So if you want to market to a clientele that is interested in higher zinc levels, you can go for a knuckle. If you want focus on a clientele that wants more iron, then you would go to a different cut. Now, when we look at the lamb industry in Australia, we've had this continual global demand for sheep meat. It's forecast to increase. There's no evidence that it's going to decrease. The price of lamb has almost tripled since 2009. And lamb retails now at more than 300% more than chicken. So it's become an elite product on the Australian market. Yes, the kilograms per head consumed per year has gone down. Of course, our population has increased also. But the great majority of that is due to the overseas market and the growth in the overseas market. And that's underpinned by providing high quality product that's tender, particularly if it's aged for 8 weeks before it gets to, say, the east coast of the United States. But we send lamb now into all these markets, into China, Japan, Canada, North America, and even into Europe. And it's rated as a very high product in the market. So now we've come sort of to the conclusion of these 3 talks. And as we think about an industry overall, and we're trying to develop a strategic plan and a way forward for the things that we should do to grow the value of the industry, my first recommendation is that you need to have all the players that are important in the process, both from the scientists to the farmers, the producers, the people that grow the animals. You've got to have processors on board, those people who process it, and then those who retail the product at the local level, particularly. The processors will be sort of the main conduit into the export market if you want to export. But you've got to have all these people working together. You must understand your consumer base and what their requirements are. So in other words, you need to know how important is, say, tenderness to Uruguayan consumers of lamb meat. What's the current level of tenderness? And that would be one of my first recommendations of what you would do. You would go out and you would test the tenderness of Uruguayan lamb as presented to consumers across the country to give you a benchmark for where you're at. Underpinning all of this, you've got to have a coordinated genetic evaluation system. This is essential to bring about change because you need to have genetic change at the production level. You need to have processing change by the integration of new technology. And you've got to have the ability to integrate all these data sources. Having said that, the investment in technology must mirror industry needs. So what are the needs of the industry? What are the needs of processors? How are they going to get the best information to feed back down to farmers to help them make changes and also satisfy market requirements? And you can always learn from others' mistakes. And certainly in that space, I can help because of the evolution that we've undergone in Australia in the industry and my involvement in the industry. So again, thank you and gracias to you. And I really hope that this has helped you think about the holistic approach to your industry and how you might move forward.